So we said we're looking at identities. So identities are just rules. So these are just basic rules that show us how these functions are related. You already know the first one that we discussed. We said tan theta is the same as sine of theta over cos of theta. We already proved this. The next one is that provided you have the same angle, sine squared of theta plus cos squared of theta is always going to give you what? A 1. That's what you have. So this is a must. You need to know this. So here I'm going to give you the common one, the usual one that you need to know on your fingertips, and also how we're going to be deriving them. So this is what I'm basically giving us here. Yeah. So aside from this, we also have, you know, these are very basic. You know what sec means. Sec theta is just the same as 1 over cos. So you know this already. I'll just put them in the same line. These are your inverse functions, right? You know what cosec is. Cosec theta is the same as 1 over sine. You know this already. Then cot of theta is simply the same as 1 over tan. You should know this already. Then we can manipulate the first equation by dividing throughout. The first time we're going to divide throughout, this guy here, I'm dealing with the second identity. So I'm going to divide throughout with sine squared. So I'll take it the way it is. I just want to show you how we can derive other identities. So I'm dividing throughout by sine squared, also this side by sine squared, also this side by sine squared. So this becomes a 1. This will change and becomes a 1 plus. This is the same as cos over sine. Now remember what cot is. Since tan is equal to sine over cos, and cot is a reciprocal of tan. So this here I must say is the same as cos over sine. Just flipping them, interchanging them. So when you see cos over sine, they're both squared. So we're just going to say this will give us cot squared theta is equal to 1 over sine is cosec, but then the sine here is squared. So this is the same as cosec squared. This is going to be cosec squared. So this gives us the fourth identity when you divide throughout by sine squared. So we can also divide throughout by cos squared. We can create another identity. So I'll just write it up. So the other identity you can have is tan squared, then plus 1. This is going to be a sec squared theta. Then apart from this, I'm going to write what we call double angles. So these are very important, and I need you to master these guys by heart because these are always going to be needed. The first one, so I'll write the normal one. I'll give us for sine A plus B, provided A and B are different or they are not the same, they're not equal to each other. This is always going to be, we have sine A, then we have, this is going to be cos B. So we say sine shares because it's going to be cos B, then it follows the rules as well. If it's a plus here, even here it's going to be a plus. Then we're going to have a sine B and cos A. Then if it's a minus, sine of A minus sine of minus B, this is going to be sine A cos B. We just change the sign there. This is going to be that, then cos A. So some people would rather just write this together at once without, instead of us writing two things like this. It's sine, so they'll just rather write it as a rule that is joined. They'll just say A, they'll say plus or minus. Then let me just indicate this here. Combine them like this. So this whole thing, what we've written here as two separate equations. So these are called double angles. So these are double angles for identities. In an event where you need to combine two or subtract two or more angles, this is basically what you have. Yes, I have said that right. More, it can be two or more. You'll see other unique cases where the angles can actually be 3 inside. All we are saying is that for sine, this is a distribution you'll get, and the distribution that you have is going to allow you to be expressing things like how we did the sine 75. You remember what we had? If I was to ask you to say, so right here, let me give us an example. If I ask you to say what is sine 75, remember what we did, because sine 75 is already in the first quadrant. So there's no complementary angle that we can use. This is already proper the way it is. The only thing we can do is look for the special angles that we can break using this 75. So we asked ourselves to say, between the special angles that we know, these guys here that we know, I mean, what can we do with them to get 75? We figured that we just had to add 30 and 45. This is how we got this, and we split it, and it became what? 30 and 45. Remember this example that I gave you last time in the previous session. So we used this double angle for cos, for sine. Then the double angle for cos, so this is the double angle for cos alpha plus beta. So cos is selfish. First is going to be cos A and cos B. Then that's when now we consider the sine function. Then you have what? Sine B, sine A, this side. Then if it's a plus, if you're saying, if it's a minus here, it does the opposite. This is cos A, then cos B, then here it's going to be a plus. Then you have your sine A or sine B. So it's okay even if you switch these guys, because they are just, multiplication is commutative, in case someone will be wondering. So let me just follow the normal way. I'll put A there, I'll put my B, I'll put our B there. Then the third one is the one for tan. So tan A plus B is just going to be equal to, we say tan A. Then here we follow the rule there, we say plus. If there was a plus there, then we say tan B. Then over 1 minus tan A times tan B. That's the rule for plus, for tan. Then for minus, if it's tan A minus B, this is basically going to be tan of A. Then we follow the rule there. That's simply going to be minus. Then tan of B. Then the guy at the bottom will be plus. Now it changes. It becomes the opposite of what's on top. So this is literally what you're going to get in terms of the double angles. So aside from this, maybe let me also add a few things. So double angles here, these double angles that we are looking at here, guys, is when A and B are different. So here, let me add a point here. When A is not equal to B, if they are totally different, that's when we use these guys here. What if the angle is the same? What if the A and B is equal? So let me just say when A is equal to B, the ones that are only going to be affected that are possible are the plus ones. What I mean is like the first one, sine of A plus B. Now, if A is equal to B, meaning we're just having A plus A, right? In the expression, then this is just going to give us, remember it was supposed to be sine A cos B, right? But this is going to be sine A cos A, then plus sine A, again cos A. Wherever there is B, we've just put A. This is just going to be sine 2A is equal to, this guy here is the same as 2. Then you say sine A, then cos A, because these are like terms. So we have something like this. Don't be shocked next time when we say sine of 2x is the same as 2 sine of x, then you have cos of x. So if you remember under projectile motion, there's one of the equations that says sine 2 theta. If you like using those equations. So there's at some point, remember I changed them to this. So this is the identity that I just used. Whenever you see sine, it doesn't matter the letter they use, guys. We're just saying, provided it's sine 2 times anything, it's the same as 2 sine that anything, cos that same anything. Yeah, so some people will be using x, some will be using a, some will be using theta. It's the same thing. Yeah, so if I give you, what this means, guys, if I give you sine 120, instead of you being troubled to say there's no special angle that gives me 120. You know to say 120 is the same as what? 120 is the same as 2 by what? 60, right? So you know to say this is actually the same as 2 sine of 60 and cos of 60. You get this answer. That's the answer for sine what? Sine 120. Yeah, so hope this is okay. Hope this helps. I'm just saying in an event where A is equal to B, our double angle identities can actually shrink. So the second one is the one for cos. And notice that I'm only using the one for plus because I cannot use the ones for minus. The ones for minus won't make sense. It's like me trying to put where there's B, I put A here. So here if I put A, right, that's going to be A minus A. Everything becomes 0. No wonder we're not changing these ones. These guys can never have a case where A is equal to B. We're only using the ones for addition. Yeah, so the addition double angles can be affected if A and B are equal. So remember this, we said this is equal to cos A, cos B, then minus sin A, sin B, right? Now we are changing this. So we're saying wherever there is B, we put A. So this is going to be A there. This is going to be cos A, then this is cos A, then minus, this is going to be sin A, and then sin A again. So this is the same as cos 2A is equal to cos A times cos A. That's going to be cos A squared, then minus sin squared this. So this is another identity that you can just keep on your fingertips. Hope this is okay. The next one is the one for tan, the addition one. So if we just change it, I'll just write it direct. This is 2A. That's going to give us 2 tan A there on top. Then down you just get 1 minus tan squared A. That's what you have. So hope this is okay. This will be confusing at first, guys, but with time you get to appreciate what we are doing here. So enough about these rules. I've sent the document that you need about the rules in the group. So now let me give you examples. Let's look at example number. So number 3, I think there was something that I avoided because it was supposed to change or needed a double angle. So let's see. This is the same as what? 4 pi over 3. So 4 over 3. So 4 times 180. Pi is the same as 180. Then divided by 3. This gives us a 240. So this is okay. This is a 240. We already solved something like this, I think. This we already did. Yeah, so which other one here? There's, I think there was something. Is it 5? Let's say 5 times 180. Then divided by 3. This gives us a 300. So all the questions here on number 3, I think they were workable using the initial small rules. Like this guy here. Let me just remind us. They want the exact value of this. Right, so tan 5 pi, so this is, we're now going to be doing examples. Let's call them examples. So on question 3, I'm doing number F. This is tan 5 pi over 3. Now 5 pi over 3, remember that 1 pi is equal to what? 180, right? So what is 5 pi over 3 going to be? So the pi can go, 3 there. That's simply going to give us this. Then multiply, that's 300. So this here is the same as 300. Now we know where 300 is coming from. 300 is from which quadrant, guys? Where is 300 located? So we're simply going to say we have this is going to be here. This is the 300 that we are having. There's 300 here. And if we are in the 4th quadrant, we know how these guys play around here. We're saying only cos is positive in the 4th quadrant. The other 2 guys are negative. So this is just going to be the same as negative tan. Then 360 minus 300 simply gives us what? A 60, right? So we're going to say negative tan of 60. Then tan 60 is the same as what, guys? We did special angles. What's tan 60 going to give us?
Root of 3 over 1.
So we can quickly always just draw your thing here. This is just the same as 2. This is 1. This is root 3. To avoid wasting time or doubting yourself. So we can just, for confirmation's sake, to be certain, we just draw this triangle. Then we're saying tan of 60 is 1. So katoa. So this is opposite over adjacent. This is just root of 3, right? That's what you get, isn't it?
Yes.
So this is basically what you're going to get. So this answers your number 3. Is there any question here, guys, on number 3 that looks confusing that we should do together? Felicitas, Namakao, Maureen. which question here, number 3, which one should we do? That looks confusing. Okay, so silence means everyone is okay. So I'll go to number 4. Number 4, they are saying, so number 4, there are 6 questions. I'll pick to do, you give me 3 that I should do, then I'll leave the rest to you. So which one should we do? Which first one should we do here on number 4? Which first question should we try out?
We do one for sec, one for cosec, and for cot.
Okay, so for sec, I'll choose this one here. The one for, you're saying the one for cot?
Yeah, one for sec, one for cot, and one for cosec.
For cosec, okay. So I'll do A, B, and E. So the first one is sec 210, the one the exact value, right? So sec 210. First and foremost, you know what sec means. So we'll simply say this is, we're saying sec 210 degrees. So this is the same as, sec is the same as 1 over what? Cos 210, right? This is what we know. Sec theta is equal to 1 over cos theta. So now we're just interested in getting what? Cos 210, that's what we want to get. So 210 is found in which quadrant? 210 is found in which quadrant, guys?
Third.
In the third quadrant. So in the third, we're measuring it like this. This is our 210. Now, in the third quadrant, the angle that we are dealing with, so let me just say this, the angle that we are dealing with, let me just confirm something. So if we are dealing with cos 210, okay, we're getting this guy, which is supposed to be negative, and the biggest angle in the third quadrant is what? Is supposed to be the angle here. So last time we said this is going to give us negative, the same as the angle we're having, minus 180. That's what we agreed upon last time. So this is going to be negative cos. Then we say 210 minus 180. The answer we're getting is a 30. So if we say we are punching, we are getting cos 30. Cos 30 is the same as what? According to our special angles. So we can just draw a thing like this. There's a 60, there's a 30, there's a root 3, there's a 2, there's a 1. So cos 30 is what? Adjacent over hypotenuse, right? So this is just the same as negative root 3 over 2. Hope you remember, guys, I gave you an interval last time to say if you're looking for anything here, you use the theta. For here, you use 180 minus that theta. Here, you use that theta minus 180. Here, you're going to do 360 minus that theta that you're given. If the angle is already acute, you punch it the way it is, solve it the way it is. But if the angle is in the second quadrant, meaning it's just a little bit lower than 180, you do this to find the complementary angle. Like if I give you cos 120, cos 120 is the same as cos 180 minus 120, which is just the same as what? That's just going to be 60, right? Put a negative here because the cosine function is negative in the second quadrant. So we said this, we corrected this in the third quadrant. We said the angle has to be measured with respect to the positive x-axis. No wonder we are subtracting from 180, because what we need is like we're saying the 210 is here. 210 ends up to here, but the only piece we have knowledge of is going to be the 30. This is the only piece we're going to be considering. And this is being worked at as if it's in the first quadrant. Meanwhile, it's not. This is just a triangle which has found itself in the third quadrant. But if we reverse everything, take it back in terms of this part, cos 30 alone is going to be treated as if it's from the first quadrant, because 30 is acute. So this is the angle we are getting, which is root of 3 over 2. But because the initial big angle, the complementary angle to 30 is 210 from the third quadrant, meaning that cos, the outcome has to be negative. That's a negative that we are putting in front. So now the question was asking for sec. So we've only found cos 210. So cos 210 now is going to be replaced here. So we're going to say 1 over, cos 210 is negative root 3 over 2. This is just going to be 1 divided by negative root 2, root 3 over 2. Then this is going to usher us into getting the sec value. This is going to be 2 over root of 3 with a negative. The answer here is going to be negative 2 root of 3. You can rationalize this and it's going to give you 2 root 3 over 3. This is your answer there. That's the exact value of sec 210. In short, this confirms something as well. If a trig function is negative in a particular quadrant, even its inverse is also going to be negative in that particular quadrant. That's what this just implies. Yeah, so cos is negative in the third quadrant. Even sec, the inverse, is also going to be negative in that particular quadrant. So hope this is okay. Any questions, guys, here? Anyone who is lost?
So the last part which you are doing, like, for example, where you ended at -2 over root of 3. So is it always that you have to rationalize, or you can leave it there?
Based on the fact that you already know what we do under SATs, you are always expected to rationalize here, because according to what you learned under SATs, we don't allow leaving a square root in the denominator. We don't allow that. It's like you have to conjugate. It's like how we treat complex numbers. So they can mark even if you don't, but just like the marking key always has something that's rationalized.
All right.
Yeah, so you just have, for precaution's sake, you just have to do that. Then we can also do number B. B is cot. They're saying cot 225. So B also an example. So cot 225 degrees. This is what we are looking for. So this we know is the same as 1 over tan, as tan 225. That's what we are in need of. So we're going to first of all get tan 225. So we know to say 225 is in the third quadrant as well, right? So even if we were to change it, so this is somewhere there. It's supposed to be the whole 225, but we're just going to subtract 180 from 225. So 225 minus 180. This leaves us with a 45. So this is the same as tan 45. So what is tan 45, guys? Tan 45 was what? What's tan 45, guys? It's simply 1. This is the common guy that you have to know by heart. Yeah. So meaning this guy at the bottom is just the same as 1. So this is also just going to be the same as 1. The reciprocal of 1 is 1. Is this okay?
Sir,
yes.
So, like for cot, you are saying it's 1 over tan theta. Can you also use the other one which you said cot is equal to cos over sine?
Cot is equal, yes, cot is the same as cos over sine. Yes, you could have done that. So it's like you're saying, now that is just going to be you prolonging things, because what comes after, what does the cot mean? Cot means 1 over tan. Are we able to solve tan 45? Yes, we can. But then you prolonging the process by saying tan 45, or rather saying, you say what, cot, right? Yes, you can say cot 225 is the same as, you want to do what? You want to say this is the same as cos. Now you would have to go look at what you're going to have. Now you're prolonging things because now you have to get this first and get this first. This is going to give you 1 over root 2. This will give you 1 over root 2, which is now going to give you a 1. So why not just go direct? What's the first thing that comes after cot? Cot theta is equal to what? That's what we're asking. It's simply 1 over tan. So get tan. Can we get tan 45? Yes, there's a special angle 45. We can get it. It's a 1. So meaning here it's just going to be 1 over 1, which is now going to be a 1. Yes, you can. My answer is yes, you can, but it's just a longer process.
No.
Yeah, but the outcome is still the same. The answer is still going to be the same. Yeah, so how about this one for cosec? So cosec, the first thing again, what comes after cosec? Cosec means what? So cosec theta, cosec 240, the theta here is 240. So 240 is the same as 1 over, you say sine what? Sine 240. So now get sine 240. Sine 240 is in which quadrant? This guy is in the third quadrant, right? So 240 minus 180. And so 240 minus 180 This is giving us, okay, 240 minus 180. It's giving us a 60, so it's here. There's a 60 somewhere there. So this is the same as negative sine 60. So we know what sine 60 is, right? According to our special angles. So with time, you'll get to master the triangle. But for now, we'll continuously always redraw it until you get used to it. So there's a 60, there's a root 3, there's a 2, there's a 1, there's a 30 this side. So sine 60 is opposite over hypotenuse. That's negative root 3 over 2. There's already a negative here because we're in the third quadrant. That's where 240 is coming from. Then we're simply going to replace here. This is 1 over negative root 3 over 2. This will end up being negative 2 over root 3. Then you rationalize this to be negative 2 root 3 over 3. So this will be your answer right here. So this is how you do every question on number 4. This is how you basically do it. Any questions, guys, here? Anyone who is lost? Any questions, guys, here? Okay. So if there are no questions, I'll proceed to number 5. So number 5 is simply, they're saying use the compound angle identities to find the exact value of this. So I'm going to do 3 from here just to give you the general idea. You'll be able to figure everything out. So I'll do this one first. I'll do sine 15. How you do sine 15 is how we'll do cos 15. Yeah, which other one should I do? I think I'll do the one for sec as well. So sec 7 pi over 12. And I also do the one for cot. I'll do the one for cot. And this here, you know, times 75 is the same as 30 plus 45, right? Also, what you get here, so what you get here as your answer, the reciprocal is going to be the answer of this guy because cot 75 is the same as 1 over tan 75, right? So this is just them testing to see if you're able to think in those lines instead of wasting time to redo it again. So yeah, so I also do h. So I'm going to do these 4. Yeah, these 4 will be enough for you to understand the principle here. So the first one is sine 15. That's what they want us to get. So example. Yeah, so they're saying sine 15. So now remember the angles we're dealing with. The only special angles we have are these guys here. So we have to always refer back to them. Yeah, so the first question you ask yourself is, what can you do with 30, 45, and 15 to get the what? To get 15 degrees. I mean this 30, 45, and 60. What can we do to get 15? What should we do, guys? Which combination can give us? Subtract.
Subtract 45 minus.
Exactly. So we're going to have 45 minus 30. That gives us a 15. So now we know there's a formula that we're supposed to use. There was a formula that we're just from learning that says sine of a minus b is the same as sine of a and cos of b, then minus sine of b and cos of a. That's what we are dealing with. According to this, our a is 45, our b is 30. So this is going to be sine. This is 45 minus 30. We're just going to do the replacements. Sine 45 cos 30 minus sine 30, then cos 45. Then you know what your sine 45 is. This is 1 over root 2. Cos 30, that's going to be what? Adjacent over hypotenuse, that's root 3 over 2, if I'm not mistaken. So this is going to be a 3 there. Then minus sine 30, sine of 30, that's opposite over hypotenuse, that's simply half, cos this is simply 1 over root 2. So this is going to be root 3 over 2 root 2 minus 1 over 2 root 2. When you add this, this just gives you root 3 minus 1 over 2 root 2. Rationalize this by multiplying with root 2, the numerator and the denominator. This will just end up being root of 6 minus root of 2. Then down you just get a 4. Because this is root 2 times root 2 is 2. So that's simply going to multiply with this 2 to give us a 4. So this is literally your sine what? Your sine 15 degrees. If you punch sine 15 degrees on the calculator and someone who punches this, you get the same answer. Is this okay, guys? Am I too fast? Should I repeat it?
Repeat. Haven't understood.
Okay. So they're asking for sine 15. Nice, sine 15. This is what they're asking for. So you look at your special angles. We have not learned sine 15. The only things that we've learned are 30 and 45 and 60. So now you ask yourself, what can you do with these three angles to get a 15 in terms of addition and subtraction? The only angles that are close to give us a 15 is 45 and 30 if we are to subtract them. So this is the part where we are subtracting them to say 45 minus 30. So this here is the same as 15. That part is okay, right? Hello, the madam who said we repeat, is that part okay? Okay. Okay, the next question I want to do is your G. G says sec of 7 pi over 12. So 7 pi over 12 is what in degrees, guys? Anyone who can quickly convert it? 7 pi over 12. It's what?
15.
It's 15. Okay, so meaning they're just simply asking us about sec what? Sec 15 degrees, right? So sec 15 degrees is the same as 1 over what? 1 over cos 15, right? So now they want us to get cos 15. So cos 15 is the same as cos of what? The same thing that we did for sine is the same thing we're going to apply here. That's 45 minus what? Minus 30. We do the same thing. This is just going to be, the difference is that cos is selfish, so it's going to be cos 45, then cos 30, then plus sine 45, then sine 30. So this is going to be 1 over root 2, cos 30 is root 3 over 2, plus this is 1 over root 2. This is simply sine 30 is what? 1 over, sine 30 is opposite over that, that's 1 over 2 if I'm not mistaken, 2 root 2 plus 1 over 2 root 2. The difference is that this guy will have a plus. This is root 2, root 3 plus 1, then there is 2 root 2. Rationalize this, you get what? You get root 6 plus root 2, down you just get a 4, right? They didn't want this, they wanted sec, right, which is a reciprocal of this. So 1 over root 6 plus root 2 over 4. This is just going to give us 4 over root 6 plus root 2. When you reach here again, you rationalize this because there are roots down. So we're saying sec of 15 is the same as 4 root of 6 plus root of 2. You rationalize this now by multiplying it with the conjugate here, which is just going to be that. This is going to be 4 root 6 minus 4 root 2. The down part will just be a 6 minus a 2. This will end up being a 6 root 6, a 4 root 6 minus 4 root 2. Then down you're getting a 4. This will end up being root 6 minus root 2. So this is the answer to your sec 15 degrees that was needed. This is what you're supposed to do.
I have a question.
Yes.
You're saying we have root 6 minus root 2. So even if the things inside the square roots are different, it's okay to subtract, or maybe they've just cancelled out.
Oh no, they've just cancelled out. You are asking about how they changed from how we moved from multiplying this to just get this?
Oh no, the top part.
The top part. Which part?
No, just there. The root 6 minus.
This part here?
No.
Which top part?
4 root 6 minus 4 root 2.
Oh, they didn't subtract. So here.
They just
cancelled. So no, they didn't cancel. Look at what happened. You're okay with the bottom part as multiplying? Let me use this color.
Yes.
So you're okay with this and this giving us this, right? So now the top part, they cannot cancel. Nothing happened to them. I wrote it here. This is the part here. There's 4 root 6 minus 4 root 2. It's still intact on top. The bottom part is 6 minus 4, which is 6 minus 2, which is 4, right?
Yes.
Then from here now, you are going to have 4 is common throughout. Can I factorize 4 on top and leave you the root 6 minus the root 2? Then at the bottom you have a 4. Can I cancel this? You are seeing how...
all right. I've understood now.
This is okay? Okay. So
the other thing is, or maybe the angle there, I think it's supposed to be 105.
the angle is 105, not 15?
Yes, when you convert.
Okay, so you are saying, let me get this right. You are saying, who gave us this? 7, you're saying 7 pi over 12 is 105?
Yes.
So 7 by 180, then divided by 12. Okay, it gives us 105, not 15. So, okay, I had something wrong. So it's supposed to be sec of 105. Okay, if you say sec of 105, right? This is now going to be the same as 1 over cos of 105. So now where is 105 found? 105 is going to be in the second quadrant. In the second quadrant, so we're saying cos of 105, meaning everything now changes. So 105 is the same as cos of what? 180 minus 105, right? So with a negative in front, because cos is negative in the second quadrant. So this would have been the correct way of doing things. This should give us a 75. And you know how a cos 75 looks like. We got it somewhere here, I think so. Or we just got a cos 15. There was no... Okay. But either ways, we know how we distribute the 75. 75 will be the same as 45 plus 30. So cos of 45 plus 30. Yeah, so this is how you break this guy down into have a negative. So let's say you get your answer to be what? Let me just check it out. You get your cos 75. Let me try to see. Okay, this is a very... Okay, unless someone who has a cash flow can get the actual value, but for us, we would have to go the native way of saying cos 45, then cos 30, then minus again sine 45, then again sine 30. The negative here has to affect everything, and I'm leaving it outside after the brackets. So this is negative. I'm having the 1 over root 2 cos 30. So 30 is adjacent, root 3 over 2, then minus. This is 1 over root 2. Then this is going to be half. This will just turn out to be... I can just flip things. Hope you'll be able to see this. This is going to be 2 root 2. Then minus 1 over 2 root 2. So the negative can affect things, and these things are simply going to be... okay, so I'll carry the negative. I'll put it as root 3 minus 1, then 2 root this guy here. So this is your what? Your cos 105. This is what we got. Now we're looking for sec 105, right? Sec 105 will be the reciprocal of this. Just switch things. Let what was the numerator become the denominator, or maybe you want me to show it like this: 1 over negative root 3, then plus 1. I've affected the negative on top. Yeah, then down I'm having a 2 root 2, so that maybe you can now have this is 1 divided by 1 minus root 3 over 2 root 2. Then this is going to be 1 times 2 root 2 over 1 minus root 3. Then this will now become 2 root 2. Then you have 1 minus root 3. Then here you rationalize, right? Multiply with this to just avoid having a sad down. Yeah, so your final answer should be something like a 2 root 2 plus a what? A 2 root 6. Then down here you just have a negative 2, which can now be simplified as negative this minus root 6. Yeah, something like that. So this is what you're supposed to get. So the correct answer to this is what we are from getting here. So because I made a mistake and took it as a 15 instead of 105. Thank you for the correction. The process is the same, guys. The concept is the same regardless. Avoid leaving a sad in the denominator. Always rationalize whenever there's a chance to do so. Yeah, so that's what you need to get. Then I'll just do one last one here. Yes.
On the angle which is 105, why didn't we use 45?
So this is our number 6. So you have to give respect to where our a are coming from. Any questions, guys, up to this point? Is this okay?
It's okay.
Okay, so if this is okay, now we can proceed and get the actual values they want. So like I'll just solve the first one. The first one, they're saying what? Or maybe let me do something that's a bit interesting. You already are familiar with sine a plus b, you know the formula. So how about something like what? Like a cot of a plus b, right? So if we were to solve, we're looking for cot of a plus b. So we're going to say cot of a plus b. This is the same as 1 over tan, right? Tan of what? Tan of a plus b. That's what they just want. So we're going to proceed by getting tan of a plus b. And this is the same as we said. This is tan of a plus tan of b. Then over, this is 1 minus tan of a and tan of b. So we already know what tan a is, right? According to what we wrote here. So tan a is already given here. We have it. It's negative 4 over 3. So we put it here. This is going to be negative 4 over 3, then plus. Tan b, we already have it here, which is 12 over 5. So we can just say this is a 12 over 5. Then here we're going to have 1 minus negative 4 over 3, then times 12 over 5. So this will give us the exact value of tan a plus b. This will just be, we sum up this. Yeah, so we're just going to say if we sum up 12 over 5, so for the sake of time, I'm just going to use my calculator here. We can just say 12. I'll just write it like this. I'll reverse the thing so that it becomes easier to handle. This guy is being divided by 1 plus, so this is going to be a 48 over 15 down here. So this is the same as that. Then this is going to give us a 15 here is a common denominator. That's going to give us a 36 minus a 20. Then here it's divided by, that's 15 plus 48, so 15 plus 48, that's 63, so I'm getting a 63 over 15 this side. And here I'm just going to get, that's a 6, that's a 1, times 15 over 63. So I'm ending up getting, we end up getting a 16 over 63. This is tan a plus b. Remember the question is asking for cot a plus b, right? Which is just going to be 1 over 16. This 16 over 63. This will now change to be 63 over 16. So that's the value for the cot. This is basically how you handle all the questions on number 6. So number 6, the key was you coming up with these two triangles. Once you get these two triangles right by following the quadrants where the angles A and B are coming from, you just be picking these. Not that I first of all wrote them here before even looking at the questions, because now we'll just be picking them from here. Yeah, so this is what was supposed to be done. Any questions, guys, here?
Sir, why were you taking 3 as negative?
3 as negative, which 3?
On the first triangle.
On the first triangle, or because of this, so everything else comes from here. So you first of all have to understand this part. They are telling us that A is coming from 90 to 270, meaning which quadrants have been cutted by, which quadrants are found as we move from 90 to 270. It's the second and the third, right? It's this guy here, the second and the third. So now, between the second quadrant and the third quadrant, where do we find the sign to be positive? Because the ratio of sign here is positive. So this is just allowing us to choose this quadrant because the sign is positive. Between the second and the third, the only place where sign is positive is the second quadrant. So only sign is positive. The other two we have to put negatives. So go like cos and tan, we have to put negatives. The same reason why we also took the other guy to be negative, because this is between 180 to 360, meaning we are given choices as from this is 180, right, to 360. That's between the third quadrant and the fourth quadrant. And B is cos, right? They're saying cos B is negative 5 over 13. So where is cos negative between the third and the fourth quadrant? Cos is only negative in the third quadrant. We're comparing these two quadrants, so it's negative here. So in the third quadrant, cos has to be negative and sine has to be negative, but tan has to be taken as positive. Yeah, so this is just us following the quadrants. That's where these signs are coming from. You can show this properly on an XY plane if you want, but it will be a waste of time. I'd rather just consider the fact that we're dealing with the third quadrant. We take the other two guys to be negative and tan to be positive. Then we use them as they are. What we've gotten here is what we'll be using in the substitutions to solve for these expressions after we expand them. So we are taking 3 as negative because we are in the second quadrant. In the second quadrant, the x component, if you are drawing a triangle in the second quadrant, you draw a triangle like this, that looks like that. This value here, this distance has to be negative. Then these two will be positive. This is positive and that's positive. That's why 3 is taken as negative. Is this okay?
Yes, I understand.
Yeah, so this is what you're supposed to have. Yeah, so you can just, sorry for this, this is so much debt. Let me try to remove this. Okay, so with you mastering this topic, because now we are learning this so that when you learn it again, when you are doing it, for those that are yet to start it when you open in your respective lecture groups, it will be like you learning it for the second time, and now you'll be relating with what you've learned here and what you're going to be learning in class. So we're trying to teach you for long-term purposes so that when the exam comes, you won't panic. You won't have to study this again. No, like it just has to stick with you. So now we're going to be finishing it in bits and pieces. We're not rushing. We're trying to store this in your long-term memory. So with that being said, you can just attempt D. The rest, in fact, just do everything that I've not solved here, which is these guys that I've not worked out. The more you look at that PDF I've sent in the group, the more you get familiar with identities. Yeah, so for today we'll end here. Then we'll pick it up from question number 6. So next time, the next session, we'll do number 7, number 8. Then we'll have trigonometric equations. That will be the next session. Then the last session will be sketching graphs. So we just need 2 more sessions. Then we'll be done with the topic. The next time we'll be meeting is under revisions in papers. Yeah, so this is enough for the day. Unless if there are any questions.